Good afternoon. I didn't expect to see so many people here today, so welcome. There are, as you leave, he says, starting at the end, as you leave and you leave feedback in the box, you'll see that there are some stickers on that table, so please help yourself to a sticker or two if you're of the persuasion of some people that like stickers. I've found that developers are quite keen on stickers, so there you go. My name's Seb Rose. I work for a company called Cucumber. Cucumber is a tool which many of you may have heard of. I hope to dispel some of the myths that surround this tool. It's not a magic tool. It doesn't do a huge amount of things. And it wasn't designed to do test automation. So there you go. Those are the key takeaways that I'm going to leave you with at the end. Again, I like to start at the end. But now we're at the beginning. And before we start, I would like to ask the people in the room, how many of you have heard of Behaviour Driven Development before today? Okay, leave your hands up if you are working in a behaviour driven way. Okay, one hand still up-ish. He's wanting to put it down. Okay, there are other words that you might have come across in the internet, in the lexicon, that I want to put it out there right at the beginning. As far as I'm concerned, behavior-driven development is exactly the same as acceptance test-driven development, which is exactly the same as specification by example. Acceptance test-driven development comes out of the US. People like Ken Pugh have written books about it, as has Marcus Gartner in Germany. Specification by example comes out of Gojko Adžik's work with his consultancy Nuri. They've all got their own books. They've all got their own adherents. Essentially, they're the same. If you try really hard and you go on the internet and you do some searches about it, you'll find matrices that show what the differences are between them. These are just plain lies and fake news. It's all about thinking about what you want to design collaboratively. And so we're going to cover some of this stuff in a little bit more detail as the talk goes on. Equally, how many of you work in Agile teams? Okay, right, so that's more than I was expecting as well. I just want to reaffirm what Agile is. So Agile is not Scrum. Agile is not Kanban. Agile is none of those things. Agile was first defined by the Agile Manifesto, but the Agile Manifesto is a very vague document that's interpreted by different people in different ways. So I've increasingly prefer to use this definition, which I first saw articulated in this format by Dan North, who coincidentally is also the creator of the term behavior-driven development. But I think that the three bullet points really focuses on the heart of every Agile method or any team that's working in an Agile way, which is that you want to work in small increments. You don't try and do too much work at once. You want to get frequent feedback, whether that's from the customers or from your tests or from somebody else, so that you know that you're going in the right direction. And Agile, in the heart of it, is about being able to respond to change. And therefore, we need to be able to understand our code. Our developers, our designers, our users all need to be able to work with the products of our development in an effective way so that we can change rapidly. And so focusing on technical excellence is critical. So whatever your focus is, that technical excellence is the excellence of you delivering some work. So if you're a developer, it might mean well-factored code with good unit programmer level tests. If you're part of the broader DevOps part of your organization, or rather, if you have adopted that sort of work, it's about being able to deploy things quickly and reliably. Focusing on technical excellence enables the agility of the team because you can respond to change and be confident that those changes are going to roll out without causing you too much grief. And that's the goal there, the absence of grief. Does anyone have any questions at this point? Or rather, what questions do you have? Nope, didn't work. Okay, that's me playing with some NLP that I heard about yesterday. Okay, so let's talk about why behavior-driven development. So there's a number of reasons why behavior-driven development and, in fact, acceptance test-driven development, specification by example, have become popular. The first one is that Agile methods don't tell you what to do when it comes to the technical part of delivering a product. So the Agile Manifesto is a beautiful manifesto. In the previous session in this room, we had it on a slide. It's got the 4 values, the 12 principles. Most of us can buy into all of them. But it doesn't say, well, how should we talk to our customers? It doesn't say what approaches should we do to create a maintainable quality code? How should we test our software? None of these things are in there. And behavior-driven development sits above Agile methods or builds on top of Agile methods to give us a set of practices that helps give us structure to some of the requirements elicitation and development and test automation processes that we need to deliver quality products. Alan Kelly, there's a lot of people here from the ACU conference, so I kind of expected to see Alan Kelly here as well. He's not here, but he did a brilliant tweet a number of years ago where he said, the way you spell Agile is J-I-R-A. So Jira is an almost, it's a pervasive tool, and many organizations believe that they're Agile because they use Jira. That's not the case. Jira is just a tool. You can use it for anything you like. But within the Agile world, user stories have become a de facto standard, and they have been imbued with all sorts of magical significance which they don't possess. And having user stories in Jira is not enough to be collaborative. You actually need to collaborate with other members of your team to have a cross-functional collaborative team. Jira is not going to help you there. The behavior-driven development community are working very hard to try and provide tools that allow us, after collaboration, once we've captured our understanding of what the product should do, how it should behave, we want to record that in a format that will act as persistent documentation, both for the team that's working on it now and for future teams that will have to work with our successful products. A lot of documentation is poor. So I'd like to know, is there anyone in the room who is happy with the quality of the documentation of their product? There you go. So this would be an absolutely amazing thing to get to, because there's a beautiful thought experiment. If you were given the choice between having no documentation or having incorrect documentation, which should you prefer? Which have you got? And so we've been working, you've all got it on your definition of done. You've got this update the documentation. You've probably got wikis with version control documentation with sign-off sheets with people saying, yes, I approve this, this is a true representation of our product. And yet you can't rely on it. You come around to looking at the product again, and you have to go back to the code. The code is the only true source of information about your product. So BDD builds on top of that realization or that insight. And then the final thing that I want to say, and there may be some testers in the room, and testers are absolutely well placed to do test automation, but only if they have some development skills. Software automation is not something that is any less exacting than software development. Development skills are essential. So this is why BDD. Behavior-driven development, though, has been incredibly hard to describe in a pithy, nutshell way ever since it was created. Dan North has tried. Actually, his descriptions of BDD have got more and more opaque and harder to parse as time went on, so we gave up using them. My colleague Matt Wynn tried to bring it back to something that could be understood by mere mortals in his book, The Cucumber Book. He did a good job, but even so, it was one sentence with far too many nouns and verbs in it. So over the past 3 or 4 years, working independently, Liz Keogh, myself, and Gaspar Norge have come up with essentially a model which shows BDD as not being a unitary thing, but a set of 3 interlocking practices. And we're going to talk about all three of them today. The first one we call discovery. Now, I know discovery is an overloaded word, and so this probably isn't, if you recognize the word discovery, this probably isn't the discovery that you are thinking about. But here what we're talking about is collaboratively working across the team to ensure that the delivery part of the team, i.e. testers, developers, performance engineers, security, etc., really understand what it is that the business would like us to deliver, and also to ensure that the business really understand what it is that they are asking us to deliver, because that's often unclear as well. Discovery is already part of all of your processes. What we've done certainly within the Cucumber organization, is we have mined our collective experience of working with teams in thousands of organizations over a decade and a half, to come up with a structured form to carry out this discovery process. We call it example mapping, and I'll go into it not in a great deal of detail, but I'll give you some pointers to look through if you're interested. Now, one of the important things about this structured activity is that you come out not just with a story, which is what we typically have in Jira, not just with acceptance criteria, which you can also put into Jira, but people often forget to, but also concrete examples that illustrate those acceptance criteria. So essentially, our observation is that stories are typically a way of deferring a conversation about some area of functionality. Acceptance criteria, also called rules or business requirements, are a way of scoping out that behavior, saying what it is our business would like us to implement. But typically, those are articulated at a level of abstraction that permit ambiguity, that allow for misunderstanding. And what example mapping allows us to do is, in a structured way, unearth and discover concrete examples that can make those business requirements clear. Following on from discovery, we have formulation. So the concrete examples that we typically see coming out of example mapping sessions or any other form of discovery workshop, they'll be drawn up as wireframes, there'll be truth tables, there will be sketches on envelopes or on whiteboards. They're just the fastest way you can show a concrete example to another member of your team and say, is this how it's supposed to behave? It's a high bandwidth, abbreviated form of communication. And any of you who've got boxes of little notes lying around your office know that a week after you've written those little notes, they make very little sense. So formulation is the process of taking those concrete examples written in your abbreviated form and turning it into business level documentation written in the domain language. So this forms the basis of our persistent documentation going forward. This feels like a very thin slice. There's going to be a third piece at the bottom called automation. And this formulation feels like a very thin slice, because what we're doing is we're just turning a concrete example from one form to another. Actually, it's a really tricky piece of work, because we have to get consensus. We are building our ubiquitous language. We're building our domain terms. We're trying to make sure that what we understand from this concrete example is the same as what our business or our tester or our UX engineer understands from this language. So it's actually quite onerous, but it's critical to successful documentation for the future. And then the third practice is automation. This is the bit that makes many people come to BDD. They don't come for the discovery or the formulation. The usual engagement model that Cucumber Limited sees is it's the QA manager that comes to us and says, we need more test automation. And they think Cucumber will solve all that because you write it in the English language or Norwegian, and it runs the automation. And therefore, now what we can do is we can get all of our manual testers writing automated tests. Everything will get better overnight. And the first thing we have to do is disabuse them of that notion. It does not work like that. So automation does link, tools like Cucumber, Fitness, SpecFlow, JBehave. They will all read this formulated documentation and run that documentation in the same way as automated tests against the software that you're developing. But the important thing to realize is that it's because everyone in the team understands the same thing, because they were collaborating during discovery, and because we've all collaborated on formulating it in the right terminology, that it becomes useful, persistent documentation, that there is value in this automation. Has anyone ever tried doing record and playback automation with, I don't know, Selenium, for instance? No? Yeah, one hand goes up. Anyone who's played with record and playback automation knows that it feels like you're getting something for nothing right at the beginning. It's so fast to create your first automation script. And then in about a month's time, you've got 300 people trying to keep those scripts running because they break every night. This automation piece is critical, but if you do it poorly, you end up with something that is just a huge maintenance burden. I've seen banks that have teams of testers, and all they do is keep their record and playback automation scripts running. This is just a waste of everybody's time and money. So we've got the 3 practices, but almost the most important part of this diagram isn't on it yet, and it's coming down the left. It's that arrow. You have to start at the top. And when I say you have to start at the top, I clearly don't mean you have to start at the top, because everybody starts at the bottom. What I should really say is, if you want to be successful with a behavior-driven development approach, you have to start at the top. You can just go and get Cucumber off the shelf and roll it out in your process tomorrow. I'll commiserate with you, but I won't be able to help you. You've got to start with discovery. The most important thing in a development organization is that learning process, and discovery is what facilitates that. So let me talk very briefly to start with about the discovery process, the method that we utilize in our training and in fact in our own organization. It's called example mapping. It was unearthed or discovered or documented, depending on how you like to look at it, by Matt Wynn. He was just consulting one day with a client, and he was trying to explain the difference between a story and the rules that govern the scope of that story, and the examples that really made the rules clear. And he had this deck of he's an Agile coach, so he had index cards with him. So as they all do, it just so happened he had a pack of 4 colored index cards. And so he started doing this bit on the left here. He started rolling these out on the table, and this visualization was really helpful to the customer that he was working with. They began to see it take shape. And what was good was that when there was a rule that didn't have any examples underneath it, it encouraged them to think about, well, what are the examples of that rule and how it should behave with the system? It also allowed them to think, when they created an example and they couldn't find the right rule to put it under, maybe they discovered something about the system that maybe it was a hidden assumption that no one had shared yet. Maybe it was a rule that we still needed to go back to the business to discuss what should it do, I don't know, on a leap year or something like that. And so it was a very powerful, simple visualization that people found useful. The other thing that he noticed was that quite often when you get into a room with your product owner or your business analyst and you ask them the question about how should it behave in this situation, the answer is, I don't know. As in, the product owner and the BA, they've done a lot of front-running work, but they don't have all the answers. They'll try and find out as many of the answers as possible, but typically the product owner in most organizations actually doesn't own the product, and there's a number of business people that they might have to consult with. They may not be experts or SMEs in their own right. So frequently in one of these discovery workshops, you'll find that the answer is not in the room. And what typically used to happen in that situation was that everybody that was in the room would voice their opinion about how they think the system should behave in this situation. And all that does is go round and round in a circle with lots of people spouting their opinion, and no decisions can be made. So the question card was almost the most important thing that came out of this, because there was a 4th color. He said, let's use the red one. As soon as we know that no one in the room has got a definitive answer, let's write it down on a question card. Someone will take that as an action, and before the next discovery session, they'll have the answer to it. So this is the discovery through example mapping. These slides will be available, and there are 2 links on it. One is to the blog post, the original blog post from 2015, where Matt Wynn describes this process, and the other is a YouTube demo that we recorded to try and show it in action. So that's example mapping. Then there's formulation. So here I am writing this formulated documentation in Gherkin, which is a syntax that's understood by Cucumber and SpecFlow and a number of other tools. It's a very simple syntax. To start with, this is a representation of a plain text file. So there's nothing magic about this. The words in blue, as you might expect, are keywords. There are some more syntactic constructs in Gherkin, but it's not a complex language. Its intention is that it should be usable by everybody in your organization. So no programming experience or knowledge is expected, and therefore it's supposed to be read as natural language documentation. And it starts with the feature keyword. It says what this feature is, what's being described, which feature, which capability is being described in this file. Then there's some text which is used to document the rules or acceptance criteria that are going to be illustrated in this feature file. And then we have scenarios. And over on the right-hand side, I have the standard hierarchy that you'll remember from the previous slide of the example mapping, which is story, rule, example. So the example is this abbreviated, fast set of information that describe a concrete situation and what's expected to take place. So this is what we use to make the rule clear. The formulation process that I described earlier is where this example gets translated into a scenario. So essentially, when you're reading a feature file, every scenario is a formulation of a concrete example that came out of some discovery process. Which means that this card, if you happen to keep them as paper cards on your table, this card can now be thrown away because you've converted it into persistent business level documentation, and because it lives next to the code, it's been checked into source control. The rule, acceptance criteria, business requirement, gets recorded at the top. At the moment, in the current version of Gherkin, that is just plain text. There's no scoping the rule to the scenarios that illustrate it. That's changing in an upcoming version of Gherkin, where the rule itself will show which scenarios illustrate it. So it's going to capture the example map in a closer, tighter way. Again, however, even with this old style format, the rule gets captured at the top of the feature file, which means it's getting checked in to source control as well, so we can throw away the rule. And then finally, we have the story. And those of you working in the Agile tool, space, will know that stories are really important from estimation, from velocity, from planning, from all sorts of things that people do with Agile processes. And there's a desire to try and find a way to fit stories into the Cucumber Gherkin format. We do not do that. So if you go back to the early days of user stories, if you look at XP, you'll remember that user stories were defined as a placeholder for a conversation. They are not requirements. They are mainly just something to help you remember that there's a piece of functionality that you hadn't discussed yet. It was a way of deferring premature requirements analysis. By the time you get to actually delivering a story, delivering some functionality, these stories should be thinly sliced. You'll have heard about thin slices through the stack. You might have heard about steel tracer bullets or green threads. The point is the stories themselves build on top of each other. A story on its own does not make any sense. And so in XP, what we used to do is we used to have what was called a confetti party. At the end of every iteration, all the story cards that were in the done column, we would tear them into little pieces, and we would throw them up in the air, and we'll dance around whooping and drinking beer, because obviously XP people were pretty hip like that. We knew how to have a great time. Yeah. Instead here, I'm just going to put it straight in the bin, because that way it can be recycled. Stories do not form part of the persistent record of your development. They're a way of remembering to do some detailed analysis, and then when they get really small, they're a way of scheduling the delivery of thin increments. But they are not requirements, and they should not be recorded as a persistent record of how you got to where you are going. However, if you're using Jira and other tools like that, you will have them forever anyway. Lucky you. Then finally, let's talk about automation. So I've got two slides here for automation. One is the general Cucumber approach, then the second one's going to be around the embedded space, which I think most people, or many people here, are most interested in. There are other tools apart from Cucumber. I should tell you, that Fit and Fitness predate Cucumber by a number of decades, and are equally good for doing this sort of work. I come from the Cucumber organization, so please indulge me. I'm going to use the tool that I know. So the way it works is that we have these feature files that I've shown you a brief example of one just a minute ago. The feature file has in it a number of scenarios. Each scenario has been formulated from a concrete example. The different lines in the scenario, the given, when, then, each of those lines is a step. So they are like instructions that the tool is going to walk through. The syntax of the feature file is Gherkin. So that's our starting point. However, I said that this is going to automate your software. This is going to run against the application that you're building. To do that, Cucumber needs to know how to do that automation. And for that, there's a concept called glue code. This code is written in multiple languages, but essentially, we have to write a little bit of code called a step definition for each step found in a feature file. So all Cucumber is really doing at this point is reading one line of natural language text and then finding a bit of automation code that someone in your organization has handcrafted and making a call across to that. That's all it does. This is pretty much the entire domain of Cucumber. So people often ask me, does Cucumber support web applications? No. Does Cucumber support services? No. Does Cucumber support this, that, the other? No, Cucumber doesn't support anything apart from the calling of some automation code, which makes it really powerful because you can put anything you like in the automation code. But it's not Cucumber's responsibility. Cucumber just reads natural language text and calls a stub method that you've created, and you can put any automation code you like in that stub method. Hence the arrow. And then out here you've got the application. And this application, if you happen to have an application written in Java, then this step definition will call through, possibly it will call direct Java code. Maybe we'll create a class and call a method. Maybe if this is a web application, you will invoke Selenium inside your step definition, and you will direct it to click a button saying login. Maybe it's a web service, and it will create a package and make an HTTP request off the web service endpoint. Cucumber doesn't care. Cucumber's entire remit is inside the green box, and you write the code in the step definition, and therefore you can interact with pretty much any application on any platform that you can find in the library that will integrate with. The standard languages that we write step definition methods in are Ruby, Java, and C#. It's not limited to that. Cucumber has been ported to multiple language platforms. So you can do it in Python, you can do it in PHP, you can do it in JavaScript. So there's loads of opportunities here. And your choice is down to the context of your organization, which version of Cucumber you use. They all understand the same Gherkin format. So your feature files are portable, but obviously your automation depends on the language that you're going to write it in. So this is the vanilla. This is the standard way that Cucumber automation is used in the community. However, early on, we realized that not everybody is going to be running on a PC. Not everybody is going to have an environment that we can work with directly. And so we came up with the wire protocol. So over here, I've got a box, and it just says device. I'm not getting into the detail of what the device is. We still have the same feature files. They're still written in Gherkin. They're probably sitting on a control box. They're sitting on a PC. They're sitting on your build server. Cucumber now has this thing called the wire file. And although there are a number of things that you can use the wire file to customize, essentially what you're doing is pointing to an endpoint and a port. So it's basically specifying an IP address and a port number. And what Cucumber is going to do is when it reads this feature file, it's going to, for each step, it's going to go to this wire file, and it's going to say, right, I need to pass this off somewhere else. There's the knowledge, the step definitions, the automation is not sitting in the environment in which the Cucumber is executing. It's sitting somewhere else. And so we're going to delegate that to the device. And so what we have here is we have a wire protocol, which is well documented, but it's a very simple, I think it's got seven methods in the protocol, and it talks over TCP/IP. So it's using maybe not the lowest common denominator, but pretty much the lowest common denominator, and it's got a very simple, and it is a very simple protocol. And then on the device, you run up a small Cucumber service. Now, I might be completely off topic here, but I'm guessing that a lot of you are C++ developers. So there is a Cucumber CPP, which comes with a skeleton service that will run up and run on a port of your choosing, and it also ships with given when then. Well, it's C++, isn't it? So it's macros. Yeah, so it comes with some given when then macros to help you write your own step definitions on your device. So essentially what happens is you're running Cucumber from Jenkins, and if you have a device that's listening at the right port, then the automation will run on your device, and the results will still be reported by Cucumber over in Jenkins or on your desktop. So I don't think it's particularly rocket science, but it's just moved, it's decoupled the execution from the parsing, and gives you extra degrees of control. What should be noted here is it's Cucumber Ruby that supports the wire protocol. So what you'll be running on this box is the Ruby version of Cucumber. You don't actually need to write any Ruby, because if all your step definitions are going to be punted over the wire protocol, then all you need is a wire file that says send them to this box over here, and over here you can write all of your step definitions in C++. There are other implementations of the listening side of the wire protocol available as well. And then finally, your step definitions here will interact with whatever application you have running on your embedded device. So again, Cucumber is not thinking, knows nothing about what you're actually trying to do here. It's just giving you a way of writing small bits of automation code and allowing them to be called indirectly from a business readable specification that's sitting on a separate box. Just going to pause there. Does anyone have anything they would like to say or ask?
So does this assume the device is like an embedded Linux, or what kind of targets can the Cucumber service run on? What is it? It requires some network stack.
Okay, so the question was what does Cucumber CPP require from the device? It's running as a listener service, so it requires a networking stack of some sort. TCP/IP is the method of interchange. I have to admit, I am not the creator or maintainer of Cucumber C++. Paolo is very active and is very easy to get hold of over the Cucumber Slack channels, or indeed via the Google groups. But yes, it does need networking. Okay, so simple diagrams to process diagrams, right? So this comes from a book that myself and Gaspar Nodge released last year called Discovery. What we're trying to do here is demonstrate how BDD fits into any development process, specifically any agile development process. I'm not going to spend a lot of time going into this diagram. It's an iterative diagram that basically says we in the BDD community absolutely buy into the idea of small increments, iterative development, and focusing on technical excellence. So we start off with your standard agile ways of working, where you're picking a story. We then have this the requirement workshop, which we run as an example mapping session. So this is where we make sure that the business and the delivery sides of the organization are aligned. After that, we get into the formulate space. So the concrete examples get turned into business language. We refine and build our domain language to a point where we can unambiguously describe the situations and everybody in the organization understands the same thing. And then automation here is about writing the automation code, your step definitions, to ensure that your product behaves, well, it tries to kick off the behavior that you expect. At the point you're writing this automation code, the functionality or the product probably doesn't exist. This is the old test-driven development, behavior-driven development conundrum. You're writing the test, not to test that it works, but to describe how it should work. I'm going to cover that in a little bit more detail in a minute when we talk about how BDD and TDD interact. Just out of interest, does anyone in the room work in a test-driven way? Are there any TDD practitioners here? Okay, so a very few. And then there's lots of testing, and I guess at some point we're going to release it. I just want to focus a little bit more in this develop cycle because that's where a lot of people will be interested. And a question that we often get asked is, oh, does BDD replace TDD? And the answer is emphatically no. TDD is a developer-level activity. It can write amazing documentation if you name your programmer tests well. It can give you huge benefits when it comes to quality levels, but it's at a level of granularity, typically, that is not of interest to your product owner or your business analyst or indeed your customer. Whereas the scenarios that you're writing in your feature file, in your domain language, are at the level that should be interesting to your product owner or your business analyst. And in fact, that's the test that you should apply when you're writing a feature file. Should this go in the feature file, or should it be relegated to a unit test file? And the answer is my product owner interested in reading it and giving me feedback? If they're not interested in reading it and giving me feedback, then it has no place in a feature file. We expect most of the automated tests still to be in the programmer test suite. So, I mean, we didn't have a lot of TDD practitioners in the room, and this session was specifically targeted, or at least specifically tweaked to fit into the embedded space. And a lot of people, I think, have issues with Agile in the embedded space because of because embedded's using hardware. Sometimes the hardware has to be developed. The delivery cadences of hardware is a lot slower typically than your Agile development team is going to be working to with the software. This is not an area that I'm going to go into any great detail. Recently, Nancy, I'm not even going to try to pronounce her second name, and Brian Shoemaker released this book about Agile safety critical systems. And the examples that she uses throughout this book are on medical devices. And she's not using medical devices as an example because she thought it was cool. It's because that's her background. So what we're seeing is that Agile has been picked up, not just in embedded spaces, but also in safety critical embedded spaces. It's been accepted by a lot of the regulators. So the FDA are perfectly happy, not just with Agile, but also with Gherkin feature files. What people want to see is they want to see traceability. So Agile is definitely working in the embedded hardware space. One of the problems, as I said just a minute ago, is the different cadences of hardware and software delivery, the different teams, the different skill sets that people have. And the issue, though, is actually a meta issue. It's about dependency between components. So in my mind, the question about we're a software team and we're interacting with hardware is not any different from we're a software team and we're interacting with this database and it doesn't change on a regular basis, or we're a software team and we're interacting with this open source framework and they're not very responsive. So as Agile teams, we always have dependencies, and typically we will have dependencies that go out with the organization, and therefore the release schedule, the cadence, the speed at which defects get fixed, they're all things that we can't control. And I believe that hardware effectively fits into the same space. I don't want to diminish the difficulty, but it's not a difficulty that hasn't been overcome in other areas. And it gets overcome by working on decoupling. So if you have a dependency, whether it's a dependency on a team next door, whether it's a dependency on a team on another floor, a dependency on a team in another building, a dependency on a piece of hardware, you have to decouple yourself from that to allow your team to move forward. The dependency still exists. You can't ship until everything else is in place, but at least by decoupling, it gives you the space to continue development and get to a place where when they finally respond, when they finally fix that defect, you're going to be able to ship. Clearly, the problem there is around being sure that your decoupling is accurate, and that, although I'm going to mention it, is a topic for a different session. So within the hardware space, the people that I've worked with, I've found three standard contexts that they're in. The first, in order of difficulty, first is that the hardware already exists. You're working with an FPGA, or you're working with a well-known chipset, or there's a device that you're just writing software for, and it already exists. So, I mean, typically, what I wouldn't do is make sure that all development is done with the hardware in place. I want to decouple. So I would be looking to create a set of contract tests or a stub that emulates the behavior of this piece of hardware, or at least the parts of this hardware that I'm interested in. And that way I can develop fast on my desktop. But I can also remove the stub and put in the actual API, the actual interface to device, and now I can test them both independently. So that gives me fast feedback, it gives me cheap feedback, but it gives me the confidence that my emulator, my stub, is working in the same way as the hardware that I'm targeting the software for. There are other benefits from doing that. For instance, people will release a new version of that piece of hardware. Or somebody in from another company will create a very similar clone, or there'll be a competitive piece of hardware that you would like to target as well. And if you've built in an interface, a decoupling layer, that facilitates, or it decouples you from the actual piece of hardware. So it facilitates the upgrading and changing of your software without having to go and do lots of monkeying around in the deep implementation of your piece of software. So the pattern that I would direct you to is one called either ports and adapters, or hexagonal architecture. Both of those will come up with thousands of hits if you look at it on Wikipedia. But essentially what we're saying is always work to an interface and make sure that the interface you're working to is something that you created yourself. And that then gives you the freedom and the flexibility to bind that interface to not just the piece of hardware that you're targeting today, but to future hardware that's going to come along. A similar but slightly harder problem is when the interface has been specified, but the hardware doesn't yet exist. So this is when people are developing the hardware and you have to write software to be available when it ships. So similar situation to previously. However, in this case, you can't run it against the hardware as well to make sure that the hardware is correct. My recommendation here would be something called consumer-driven contracts, where what you're doing is you are writing an emulator or a stub to allow you to move forward with your software development. But as you do that, you create a set of contract tests that you can supply to the hardware manufacturer. Now, there's a negotiation to be done there, but those contracts can be run against the hardware. They will probably have an emulator in-house of what they're designing anyway. So this gives them the ability to give you early feedback about whether your assumptions of how their hardware, how that interface is going to behave are correct or not. And so consumer-driven contracts have been around for a long time. They've become much more popular over the past 5 years. I'm particularly keen on an open source tool called Pact, which is actually targeted mainly at web services. So conceptually it's in the right space, but it won't fit into the embedded place just yet. And then finally, and harder, is if you're trying to develop, your team is trying to develop hardware and software in parallel. And at this point, consumer-driven contracts between your teams are exactly what you need. It's a way of collaborating and communicating, saying, this is how I think it should behave. Is that how you expect the hardware to respond once it's been built? And now you have a formalism by which you can communicate in short iterations between those members of the team who are more focused on the software delivery and those members of the team who are more focused on maybe FPGA programming or the hardware. So that's most of what I've got to say. I've got 10 seconds left, so I'm going to overrun slightly. A few things that BDD isn't. So first off, BDD has nothing to do with the keywords given, when, and then. So the next time you see a framework that says it's a BDD framework because it uses the words given, when, and then, doesn't mean don't use it, but it's got nothing to do with BDD. These are just words out of the English language. Equally, BDD is a collaborative activity. It's not a way of the BA or the product owner just writing more or different documentation in different structure and then throwing it over the wall via Jira or whatever mechanism they have for communicating with the delivery team. It's a collaborative activity. It's not a new way of writing big upfront design that's going to be cascaded down from business to delivery. It's also not about automated testing. You remember we was talking about discovery, formulation, automation. Automation is what everybody wants, but it's a secondary byproduct of following the process. If you just use Cucumber, or indeed any tool for doing automated testing, you will have problems around the maintainability and understandability of your tests. If you've ever looked in an HP Quality Center in an organization that you work in, and you've tried to read through some of those manual test scripts, you will know that very quickly these things become unintelligible. No one can remember why they were created or what risks they were trying to address. So BDD is not about automating those tests. It's about reframing the discussion around behaviors that the business want and concrete examples to make those behaviors clear and unambiguous. And once you've done that, now you're in a great place to automate. And then finally, BDD doesn't replace TDD or indeed any high quality technical practices that you have. BDD is an adjunct to successful and quality agile development processes. So the final takeaway is that BDD is a set of collaborative practices, 3 collaborative practices that support agile software development. And I want to add, just for the benefit of anyone who's still in any doubt, I believe this works in any context. So it works in software on its own, software with external software dependencies, software with hardware dependencies. And if you're interested, the BDD books, book 1 is out, book 2 is coming. There's a book about Cucumber for Java, and that's me done. Thank you very much. We have run out of time, so if you want to go dash straight out to coffee, please leave some feedback and grab a sticker. But I'm happy to take 1 or 2 questions if that's okay with the organizers. Does anybody want to ask a question? Him again.
Who's using it for embedded? Do you know anyone, or is it?
Yes.
That you can talk about?
No. But I can tell you offline, yes, it's being used. It's being used heavily in various medical devices, and in fact in some printer manufacturers as well. Yeah.
So, if you're coming back to or changing behavior over time, how is there a set of rules or a nice way to do that? Because with all kinds of requirement management, that's always and in Agile, that's always a pain. This is the scenario I have now. Scenario is changing. I'm not adding to it, I'm changing it.
Yep. And so there are 2 typical ways of that happens. If it's within a team that already knows how the system behaves, what they do is they find the requirement that is the scenario that's changing, they edit the rule, they modify the scenarios, the relevant scenarios, they run them, they fail, and then they go and change the code. A more typical experience that I've had is where you have an organization where the product's been shipped and now it's either a maintenance team or a new project has been spun up to do an enhancement or something like that. They don't really know where everything is. They read through it. They maybe change a few scenarios but miss others. And now what we get to is a really nice side effect of this process, which is the documentation tells you when it's out of date. So you write a scenario about how the new behavior should be. You see it fail, you then go and change the code to make that behavior, to implement that behavior. Now the scenario that you've just written is passing, but maybe 1 or 20 other scenarios have started failing. So what's happened is that the documentation is saying, well, you've implemented this new thing and you've documented it effectively, but also there are these other elements of the documentation which you need to consider. Have you introduced a defect, or has the requirement change. So essentially, it's giving you immediate runtime feedback that potentially the documentation needs changed, or potentially you've introduced a defect. Thank you very much.